Hello, everybody. Hope you're all doing well. I wanted to do a little review of the unit circle and also show you an alternative way of thinking about this information. Because as you can see, this is a lot of numbers, and it can get to be kind of difficult to remember where we're at, which one's which. A lot of the numbers are really similar too, right? Just looking at these, we have root 3 over 2 and 1 over 2, and here we flipped them. So it's really easy to mess these up. Um, so personally, I don't even use the unit circle, but I recognize that most students learn the unit circle, so I did want to talk about it a little bit, although I think Mr. Bay will be presenting a more in-depth explanation of the unit circle in a video that he makes. So let's get into it. So there are a couple things you need to know about the unit circle. It's called the unit circle because the radius of this circle is 1 or 1 unit, right? We can see that by taking from the center of the circle to over here, right? We're along the x-axis. That is a distance of 1 unit. Another thing you need to know is that all of these coordinates are measured cosine of the angle for the x and sine of the angle for the y. Okay, and how you read this, we can look at a couple examples. If we want cosine of 30 degrees, we can look and say, okay, here's 30 degrees, and I know cosine is the x coordinate on the circle. So it would be this value, which is root 3 over 2. Similarly, if we want, well, let's do sine. If we want sine of, I don't know, 5 pi over 6, we go to 5 pi over 6. So this would trace our angle right here. That's our theta, 5 pi over 6. And we would look at the y coordinate of 5 pi over 6, and that is 1/2. Okay, if you wanted to find tangent of theta, then you're gonna have to do a little bit of work. It's not explicitly written on the unit circle, but we can use the relationship that's tangent of theta equals sine of theta over cosine of theta. This is a really useful trig identity. It's one of the most used ones, I think, for our purposes in AP Calc. So let's find the tangent of 4 pi over 3. Just didn't say this before, right? We have our degrees and our radians, two different ways to measure angles. A whole circle is 360 degrees. A whole circle is also 2 pi radians, okay? So from here to here, that would be pi radians. But if we were to start in the same place, we always start here on the positive x-axis when we're measuring angles from the unit circle, if they're positive angles. We go counterclockwise all the way around. That would be a positive 2 pi radians. We can go the other way. We still always start here on the positive x-axis. If we go the other way, we're going negative. So this would be negative 2 pi radians because we went clockwise. Okay. So tangent of 4 pi over 3, well, that's like sine theta, or sine 4 pi over 3 over cosine of 4 pi over 3. Sine 4 pi over 3 is the y coordinate at 4 pi over 3. So we have negative root 3 over 2 divided by cosine at 4 pi over 3, which would be negative 1/2. And then you can simplify this by doing some, we're dividing two fractions. We have a complex fraction. What we do here is we flip the denominator and multiply. When we do this, you can see that you cancel these out. The negatives become a positive, and we're left with √3/1 or just √3. So it's a little more work for tangent. Not too bad, but a little more work. Like I said in the beginning, this is a lot. It's a lot to know. So if you know how to read this and you're allowed to use the unit circle on a test or an exam, that's great. But what if you aren't allowed to use it and you're expected to memorize it and recreate it on your own? For that, all right, this is gonna look a little scary. It's a lot of stuff, but I'm gonna explain it. For that, we can use the reference table. The reference table is an alternative way of memorizing the information that we see in the unit circle. All right, so there's a really nice pattern that makes this a lot easier to memorize. And I will be providing you with a PDF of this whiteboard so you can reference the reference table. Okay, so here's a pattern. We start at our angle theta. Oh, and I haven't filled this all in yet because I want to show you some stuff. We started our angle theta, and we start at 0 radians. I've put the degrees here, the degree equivalents, but if there's no degree marker, that is measured in radians. All right, so this is 0 radians, which is 0 degrees, and that corresponds to this column. This is pi/6 radians, which is the same as 30 degrees, and so on. Quick note here, pi/6 is 30 degrees, but pi/3 is 60 degrees. That always helped me figure them out. Okay. So we read this by choosing one of these angles and then choosing the trig function that we care about, and then finding the row of the trig function we want and the column of the angle that we want. So for example, sine of 0 radians, we look at the sine row, we look at the 0 radians column, and this is where they meet, right? We're in the sine row, we're in the 0 radians column. So that is 0 or square root of 0 over 2. And of course, we could just rewrite this as 0. But you might see this pattern, why I wrote it in this strange way. We have √0/2, √1/2, √2/2, √3/2, √4/2. So we're just adding 1 to this bit each time. Another nice thing about this is the cosine. It just does the opposite. It starts at 4, and then it decreases 1 each time. Okay, so going through, we can simplify this a little bit. √1/2 is just 1/2. This is gonna stay, we can't make that look nicer. This is also gonna stay, we can't make that look nicer. And here the square root of 4 is 2, divided by 2 is 1. Similar over here, right? This one, √4/2, we see √4/2 over here, it's still 1. This one we're gonna leave, we can't simplify it, we can't simplify it. This one is 1/2, and this one is 0. All right, but I didn't give you tangent. Why? Well, because as we talked about, tangent of theta is the same as sine theta over cosine theta. So the way we get tangent, or the row for tangent, is we just do this one divided by this one gives us this one, right? So 0 divided by 1, that gives us 0. A half divided by root 3 over 2. Well, that's the same as a half times 2 over root 3, which is 1 over root 3. And if we, let me write this out. So 1/2 divided by root 3 over 2 equals 1/2 times the reciprocal of this fraction, 2 over root 3. These cross out, we're left with 1 over root 3, and we don't typically like radicals in the denominator, so we can rationalize, or I think it's called rationalizing this, by multiplying it by a fancy 1. Root 3 over 3 is just equal to 1. It's just a fancy way of writing 1. But when we do that, notice what happens on the bottom. Root 3 times root 3 is just 3. On top, we get root 3. All right. Over here, we got root 2 over root 2 divided by root 2 over root 2. Well, anything divided by itself is 1. This one is kind of a pain, like this one was, finding root 3 over 3. You can go through the same process, take this, divide it by a half. That's the same as taking this and multiplying by 2. Those 2's cancel, and we're left with root 3. All right, just the same using this identity there. And for pi over 2, we have 1 divided by 0. That is undefined. All right, so a question that might be on your mind is, okay, this is great. This is less to remember, kind of, than the unit circle, but this isn't all of the angles, right? I've only talked about 0 to pi over 2, 0 to 90 degrees. So if we look at the unit circle, that's from 0 to pi over 2. That's a fourth of the unit circle. We need to know the other 3/4 of the unit circle. Well, there's a really easy way to do this using a mnemonic. And the mnemonic is you draw this and you think all students take classes. All right. All means all trig functions are positive in this quadrant, which is quadrant 1. Q1, quadrant 1. Students, S, means sign is positive in this quadrant, Q2. Take starts with a T, so we have tangent is positive in Q3, the quadrant that take is located in. And you probably see the pattern now. This is classes, starts with a C. So we have cosine is positive in quadrant 4. Quadrant 4. Okay, there's one more thing you need to know here. Because we know that tangent theta is sine theta over cosine theta, if we know that tangent is positive in quadrant 3, then we either have that sine and cosine are both positive, or sine and cosine are both negative, and the negatives cancel out to give us positive tangent. This is what happens here. In quadrant 3, sine is less than 0 and cosine is less than 0. Another way you can think about this, if sine and cosine were positive in quadrant 3, we would have just said all, right? Just like we did here. So this might be new, so I want to go over this again. So this mnemonic device describes which trig functions are positive in which quadrant. Here we have all trig functions are positive in quadrant 1. Here, student starts with an S, so we have sine, which also starts with an S, is positive in quadrant 2. Everything else, well, everything meaning tangent and cosine, are negative. Here we have take in quadrant 3. Take starts with a T, so tangent is positive in quadrant 3. And sine and cosine are negative. And here we have cosine for classes. Cosine is positive in quadrant 4. Sine and tangent are negative. Okay, so how does this help us deal with the angles that are missing here? The good thing about the reference table is it's less to memorize than the unit circle. The bad thing about the reference table is we do kind of end up using the unit circle anyway. So if we want something like, I don't know, sine of 7 pi over 6. If we're using the unit circle, we can just say, hey, that's the y value when theta is 7 pi over 6. So this would be negative 1/2. If we're using the reference table, we say, hey, I've seen pi over 6 on the reference table. Sine of pi over 6 is 1/2. And I know that 7 pi over 6, which is what we want for our angle, is in quadrant 3. And I know that sine is negative in quadrant 3. So you take the value of sine of pi over 6, and then you change the sign if you need to based on this mnemonic device. Let's do another example of that. Let's say I want cosine of 5 pi over 3. Well, I know that cosine of pi over 3 from the reference table, we go to cosine, that's this row, we go to pi over 3, that's this column, we know it's 1/2. So I know that cosine of pi over 3 is 1/2. I can use this number, but I need to figure out the sign here. Is it positive? Is it negative? 5 pi over 3 lands us in quadrant 4. And using this mnemonic, we see that cosine is still positive in quadrant 4. So it turns out they're equal here. These two are equal. Okay, let's do a little more challenging one. If I want tangent of, I don't know, 3 pi over 4, let's do that. Well, I know that tangent of pi over 4 is on my reference table. I found tangent, I found pi over 4, tangent of pi over 4 is 1. Now we need to figure out what quadrant 3 pi over 4 is in. I'll draw a mini unit circle. This is 0, but it's also 2 pi. If we start and go all the way around, right? If we start here and end here without moving, we're at 0 radians. But if we start here and move all the way around, we've gone 2 pi radians. This means if we go halfway around, that's pi. A quarter way around, we cut pi in half. That's pi over 2. And this would be 3 pi over 2. 3 pi over 4, the angle we care about, is a little bit less than 4 pi over 4, which is pi. So it puts us in quadrant 2. So we look at our mnemonic. We look at quadrant 2. We see that students stands for sine is positive here, which means tangent is negative here. So tangent of 3 pi over 4 is not 1, but negative 1. All right, so this takes some practice getting used to just how this works. I will say that if you're really comfortable with the unit circle and you have it mostly memorized, it might just be easier to finish memorizing the unit circle. I'm always hesitant to bring up this reference table method because it can be potentially more confusing if you've already spent a lot of time looking at the unit circle. So you by no means have to use this. I personally like this because 1, it's less information to memorize. You just have to use a little more logic to compensate. And 2, you can see this really nice pattern that we described earlier. If you have any questions about this, I'd be happy to answer them during class or during asynchronous class. Just let me know. I will have Ms. Rose post these for you, and I hope you have a great night. Thank you so much.